lying tongue. Do not be free. Never comment on the subject you don't know anything about. That's the only way to be free from life. You know, this part of the world, people lie anyhow. They go on television over what he does not know. You say yes. The economy, he has not read any book on economy. He's making comments. So he said, this comment, how did they start lying? The easiest way not to lie is to keep quiet because you don't know the topic. People lie. No, lying is not. He has no idea of what they are talking. He's on television. Talking. Because everybody has to talk on television. And he's contributing something he has no. The easiest way to stop lying is to never to make comment over a subject you don't know anything about. And never follow a liar because you lie. Ask me why. When someone is lying and he turns to you and says, it's not true, because it's your friend, say yes. You will not know when you say yes, but two of your friends. You say, that I'm talking, I think it's like that. You say yes, yes, yes. So the easiest way is to, some people lie. Lie, they don't think. It's on the spot, just close it. The only thing they don't lie about is good morning. Even when they say good morning, you have to look at your time.
Father, we thank you for today. Thank you for your message as the start. Holy Spirit, we ask and pray. Your presence start with us, grant us understanding in the name of Jesus. In Jesus' name, I pray. Okay, wonderful. We'll be starting off with waves. Waves are waves is a very broad topic, very, very broad, and I believe you've gotten to understand something. You've heard of wave, so I will need an understanding of wave. What do you understand on wave? I'd like to know, okay, what basic understanding have you got on wave? What do you think about waves? Yep. What have you I guess what do you just tell me anything you think about wave?
It's a turbulence or
Sorry?
disturbance of one or more quantities.
Sorry, I didn't get that. What did you say?
It is a turbulence or disturbance of one or more quantities.
Okay, is it turbulence? That word looks very big. Are you sure you're not looking at somewhere?
No,
Eh?
no.
Okay, wave. Now we're going to be looking at some of the basics of waves we need to understand. Now, when we're talking about waves, we're talking about wave. Number one, first thing we should know is that, please write this. A wave is a disturbance. A wave is a disturbance. That's the first thing we should note. That a wave is a disturbance which travels through a medium. A wave is a disturbance which travels through a medium and transfers energy from one point to another. A wave is a disturbance which travels through a medium and transfers energy from one point to another without causing any permanent displacement. Without causing any permanent displacement of the medium itself. Without causing any permanent displacement of the medium itself. Okay, now what we're trying to say is this, that if you drop a stone of water, you drop a stone into a water or into a basin, into a swimming pool, you observe ripples, or we call them waves, will be seen spreading outward from the source of the disturbance. Now, once you put it, you just discover it moves. Now, as the wave generated spread out, they transfer energy from one point to the other without the water moving in the direction of the ripples. Now, such things are what we call as wave. Now, another thing else again is waves can also be produced when we tie one end of a rope to a wall, we hold the other end and make it to move up and down, like it's moving up and down. Now, that alone, that can also be a wave. So these are, but in for waves, there are some techniques or there are some things we need to understand, like some terms, some terminologies we need to get hold of. I believe I spoke about it during that's the last time we met concerning in simple harmonic motion. We'll be hearing some of those terms again. Some of those terms we discussed, we talked about. So let's look at terminologies as applied to wave motion. I want to look at some terminologies as applied to wave motion. Terminologies as applied to wave motion. One of such is crest. Crest. This is a now what do you understand as crest? This is a region of maximum upward displacement. This is a region. This is a region of maximum upward displacement of the particles of the medium. This is a region of maximum upward displacement of the particles of the medium. Okay. Coming. Let me see if I could get some of this. Let me see if I could get them out. So, okay. The next one is trough. Coming, trying to get it out. Okay. Now, the next one is trough. Trough. This is a region of maximum downward displacement of the particles. A region of maximum downward displacement of the particles of the medium. So that is the trough. Okay. We also have coming. We also have the phase. Particles of a wave are said to be in phase when they are the same vertical distance from the mean position and are moving in the same direction. I think the only different thing we've not talked about in simple harmonic motion the last time we talked about was crest, trough, and phase. For amplitude, we know it as the maximum displacement of the particles, and period, the time taken for a particle to complete one oscillation. So uh, this is what we know as, okay, to cover one wavelength, whereas the period is to cover one wavelength. All right. Okay, please let me know when you're done. the terminologies. Frequency is the number of complete cycles of vibration. Frequency is the number of complete vibrations or cycles. Frequency is the number of complete vibrations or cycles that a particle make in 1 second. Hello, are you there? Are you there? Okay, from here now, this is the top here. You can call it, this is the crest. Now the crest, from here to this part is our amplitude. From here to here is our wavelength. Now the wavelength has a sign lambda. So it's we have it like this. Now we also have the trough. Now we have the trough. Now to complete the number of complete vibration in a particular second can be called the frequency. Now this is how a wave actually look like. This is how it looks like. So having understood this, the next thing we'll go into is let's look at the mathematical relationship between frequency, wavelength, and velocity. Remember the wave speed, we can still call it the velocity because we know fully well that speed and velocity are related, isn't it?
Yes.
Velocity is just speed in a specified direction. So that alone gives us an understanding of what we're talking about. So I'm trying to see if I would have any video here. Trying to see if have any video, but if not, I mean.
So your business isn't on Wix yet? Forget whatever video you're about to watch. Head over to Wix e-commerce.
That's perfectly wrong. The wrong one. Oh, good. What's this? You can still hear me, right? Hello. Okay, can you hear me, please?
Yes, sir.
Okay, so for this. The wave velocity v, we said this is the distance at which the wave travels with time. And the unit of that is meters per second. Now, please write this. Wave velocity v is equals to distance over time. Wave velocity v, we understand it's distance over time. But remember, in terms of wave, we know that during one cycle, that the distance traveled, please check all the terminologies I gave you. The distance traveled, what are we talking about in distance traveled? Which of
Wave
them
speed.
has to do with distance travel?
Wave speed.
Wavelength also. So that means if wavelength has to do with distance traveled, so that makes us believe and that makes us understand that V is equals to that means wavelength divided by time. That means V is equals to the wavelength divided by time, and that helps us know that V is equals to the wavelength over time. So because of that, but we know definitely that frequency, is what we call it. Frequency is what's the formula for frequency again? You know definitely what's the formula for frequency? Are you there?
Yes, sir.
Okay. When it has to do with time, in relation to time, what's the formula for frequency?
Um, 1 over
Okay.
period.
It's one over what?
T over
You
T.
said?
1 over T.
Yeah, 1/2, which is 1 over time. So with that now, I'm coming. But we know definitely that F is equals to 1/T. And if F is 1/T, that means this is
Why?
lambda
What's what? It's not true.
times
You can't say what you say.
what's this now? Now times 1/T, right? And that's equals to lambda F. So that means V is also equal to lambda F. Right. Do you understand that?
Yes.
Okay. So if V is equal to lambda F, now we also know that lambda is V over. No, with all this now, that's lambda is equal to V over F, which is the same thing as VT. Now, having known this, let's solve a simple question, on this. Let's solve a simple question on this. And the first question we'll be solving is a wave travels a distance of 100 meters. Let me see if I could bring it up. Okay, a wave travels a distance of 100 meters in 5 seconds. Time between the successful crest of the wave is 25 cm. Calculate the frequency of the wave. Okay, is this something you can try?
Yes.
Okay. You do that? I need to see your workings. How did you do that? Is it something you think you can show me? What did you do? Okay. Oh, okay. You just went very fast. Oh, okay. Now, a wave travels a distance of 100 meters in 5 seconds. Now, this is quite okay. I now see what you did. I think what you should just do is first and foremost get your velocity. Velocity, since you have distance in 5 seconds, remember velocity is distance over time, displacement or distance over time. As when you're talking about speed, now we know that is 100 over 5. Now that gives you 20. This is in a bit to get your velocity. And remember that we've already proven that V is equals to frequency times your wavelength. Now, the distance between two successful crests of the wave, as long as it's that's actually the wavelength. Now, the wavelength here, they are actually measured in meters. So 25 cm, that would be over 100, converting it to meters. Okay, which is the 0.25. Now, with this alone, okay, let me just erase this. Now, with this alone, we have a frequency to be equal to the V over a lambda, which is 20 over 0.25, which is equals to 80 hertz. Boom. So that is it. This is what I did here. I said the first thing to do is the first thing to do was V is equals to distance over time. We are interested, since we have a wave travels a distance of 100 meters in 5 seconds, we can easily get a velocity from there. We can easily get a velocity from there. So from there, so what I just did was, okay, I got my velocity here. Since they said it travels a distance of 100 meters in 5 seconds, so I was able to get the velocity, which is 20 meters per second. Now, but we understand that V is equals to frequency times wavelength, right?
Yes.
Okay. Now, the wavelength, which is 25 cm, is actually measured in meters, the distance in meters. So I did 25 over 100, which is 0.25 meters. Now, we know from here that frequency is the same thing as V over lambda from this equation. And V, which is 20, divided by 0.25, that gives us 80 hertz. Do you understand that now?
Yes.
Right. Okay. 80 hertz. All right. I'll be clearing this now so we can give way to another question. All right, please. This is the second question. Another question that the frequency of the vibrating source is 450 hertz and the velocity of the sound it produces in air is 330 meters per second. Find how far the sound travels when the source completes 50 vibrations.
You understand nothing. Yeah? That's the reason.
Okay. Now, considering what you've done from this question, okay, I quite understand what you did, and it looks as if it's a bit correct, but there's just one issue there. They said the frequency of a vibrating source, you just said is 450 hertz, 450 hertz, and velocity of the sound it produces in air is 3 meters per second. Find how far the sound travels when the source completes 50 vibration. Remember what is frequency? Remember that frequency, uh, the number of vibration in one frequency is actually the number of vibration, the number of circles, the number of vibration it makes in 1 second. So that means frequency is also the same thing as 1 over t. Frequency is also 1 over t. Now, with this understanding we have about frequency, now the frequency of a vibrating source is 450 hertz. That means if one of the first thing we need to get here is the time, since we are looking at how far the sound travels when the source completes 50 vibrations. Now, for it to complete 50 vibrations, that's the time for 50 oscillations. The time for 50 oscillations will be that coming will be that t, sorry, What am I doing? Time will be that T is equals to 1 over, that's 1 over 450. That's T is 1 over frequency times the 50 vibrations. Now, if we do this now, please do this for me. That's 1 over 450 times 50. We should be having this cancel this. That'll be, we should roughly be having 1 over 9 seconds.
0.11.
Sorry?
0.11.
0.1 seconds. 0.1, right? Okay.
Yes.
Now, if this is 0.1, we know definitely that to get the distance now, remember I also gave you a formula in the previous time. I also gave you, do I still have that here? Okay, I didn't write that here. With this now, this is the time to take for 50 vibrations. Now they ask us to find the distance, how far the sound travels when the source completes 50 vibrations. Remember, lambda, that's the distance, is can also be, you did it as, you said V over F, which is the same thing as V times 1 over F. And remember, what is 1 over F? 1 over F is also T, right? 1 over F is T, isn't it?
Yes.
Okay. Now,
Yes.
and that's that formula for lambda. If 1 over F is T, so that means lambda is equals to 330 times 0.1. That will give us what? That should give us what? No, the calculator here.
Thirty-two.
Sorry?
32.
Now that's 330 times 0.1. Sorry. Okay, times 330. Now, this was not just 0.1. I just checked it. That was 0.11, right?
Yes.
Okay, that will be 330 times 0.11. Okay, that should be 36.6, right?
6.3.
36.6, right? Okay.
0.3.
That was
36.3.
no. I used 330 times 0.111.
Okay.
0.111. That's 36.63.
Yes.
Okay. Okay. So that's the way to go about it. When things like this are being given, you don't just solve it. You must find a way to look at the question and look at the other what it entails. Because there are some other things it entails from that question. All right. We still have about 5 more questions so that we get used to the kind of questions that we can expect. Okay, now let's use this one also. Sorry, I did not talk about. If you notice, I kept some notes that period t is the same thing as small letter t divided by n. That is time divided by number of oscillation. Please note that down. That big T, which is the period, is equals to time over the number of oscillations. Big T is equals to time over the number of oscillations, and frequency is equals to the number of oscillations divided by your time. So please note that down. That's very, very important. Okay. Have you written that down, please?
Yes.
Okay. Take the next question. The next question is: a radio station broadcasts at a frequency. A radio station broadcasts at a frequency of 300 kilometer hertz. If the speed of the wave is 3 times 10 raised to the power of 8 meters per second, calculate the period and wavelength of the wave. The two, a long rope is fixed at one end and the free end is made to oscillate in one plane at right angles to the rope. Successful crests are 0.6 meter apart. Calculate the speed of the waves. For what frequency the wavelength be 30 cm? Okay, the first one. Okay, try see what you can do in the first one. Sorry, you said the period is what?
0.002.
0.003. What's the wavelength?
900,000.
900,000. Seriously? How did you do that? How did you do that? Okay, correct. Okay. Oh, what was the question? Can you read the question out for me?
A radio station broadcasts at a frequency of 330 Hz.
Okay,
If the speed
did I
of
tell you 300 or 330?
330.
Oh, I told you 330. Really? Oh. because I lost the question. I thought it was 300. Okay. 330 kilohertz, right?
Yes.
So you did not convert this kilohertz to hertz. Or did you forget that? Did you convert it to hertz or you just used it like that?
I use that.
Oh, you should have converted it. I think that's where the issue is. Okay, but at least your solving was correct. It's just the fact that you did not convert it to hertz. Because whatever thing you are getting, that means you should still be having it as kilo. So
Yes.
you need to remove it. You need to remove that away from kilo to hertz. Okay. Your period was what?
1/300,000.
Sorry.
1/300,000.
Okay, 1/300,000 is three times 10 raised to the power minus 6, right?
Yes.
Okay, and your wavelength is what?
And 1,000.
1,000 meters, right?
Yes.
Awesome, awesome. So the second one,
The speed is 2.4.
you said the frequency is 2.4,
The speed
56.4. Please, can you show me how you did that?
2.4, 2.4.
2.4. Okay, show me what you did. 2.4, 2.4. How did you do that? The long rope is fixed at one end and free is made to oscillate in the other plane to the rope with a frequency of 4 hertz. Can you just show me how you did that? Oh, frequency is 4, and they asked to find said calculate what frequency with the wavelength. Okay, okay, continue. So tell me, what are you trying to do? You're trying to get the period first?
Yes.
Period. Okay, awesome. Now this is the velocity, the speed. This is the speed. I saw her when she came there, don't worry. She has been there for quite some time. And both of us have been interacting with each other, so you didn't know. Don't worry. Okay, velocity is 2.4 meters per second. Also, now the next thing is the other one, which is the frequency. So they said for what frequency will the wavelength be 30 centimeters?
It's
Frequency wavelength 30 centimeters. So what is it?
it's
You said?
hertz. It's hertz.
It hertz. Correct. Awesome. Okay. I'll be. Let's see. I'm gonna be fixing some assignments now for you. I'm trying to see some of these. The next time we'll be talking about wave motion. Sorry, the wave equation. The wave equation, but let me see if I could still fix up some.
What's the?
You said what?
No.
Okay. Okay. Oh, you could use your phone to snap it instead of writing them down.
Okay.
And then okay. Okay. Have you snapped them?
No.
Sorry?
No. Yes, I snapped it.
Okay. You snapped it, right?
Yes.
First one, you snapped the first one, right?
Yes.
Okay. Is it clear? I want to delete it.
Yes.
Okay. Let's see this. Wow. Okay. The other one is an objective. Yeah, objective questions. Okay, let's do this way. These objective questions are okay. Let's do it this way. Snap this first side. So I'll be pushing it up. I'll be taking it up.
Okay.
I'll be taking this up. Or did I just, why don't I just put them in Word document and then send it to you?
Okay.
I think that would be awesome. Did you snap it? Did you in any way snap it? Yeah?
No. No.
What I'll just do is